So there are some techniques that are commonly employed to solve quadratic equations. Let's take a look at those.
Here's a simple equation in which there's an x squared term, but no term with just x. To solve it for x, let's restate it so that we can find the value of x when y is 0. So we can add 8 to both sides to isolate the x squared term. Then we can divide both sides by 2 to eliminate the coefficient. And now we can find the square root to determine the value of x. Now the primary root of 4 is 2, because 2 times 2 is 4. But there's also a negative root, because negative 2 times negative 2 is also 4. So x is plus or minus 2. In other words, when y is 0, x is 2 and negative 2. From this, we can also determine the x value for the line of symmetry. It's exactly halfway between the two known x values. So in this case, it's at 0. And with this information, we can solve the equation to find the value of y when x is on the line of symmetry, which will give us the vertex. In this case, x squared is 0, so y is negative 8. Now that we have all of these points, we can extrapolate the entire parabola. Okay, how about a more complex quadratic equation? This time there's an x squared term and an x term. Just as before, we'll solve this equation for x when y is 0. So first we'll deal with the constant by adding 12 to both sides. And now here's the clever bit. We need to make the entire left side of the equation into a perfect square so that we can use the square root method like we did before. And I'm going to do that by adding 4 to both sides of the equation. Why am I adding 4? Well, remember that you can factor a perfect square using the formula a plus b all squared is equal to a squared plus b squared plus 2ab. We already have our a term, it's x, and we already have our 2ab term, it's 4x. So our b term must be half of 4, so 2, which when squared is 4. And by adding 4, we've completed the square, and now we can factor the perfect square like this. Now that we've got that, we can go ahead and use the square root method, which gives us x plus 2. And then we can subtract 2 to find x. Let's take a look at another one. This time we'll solve it for y with respect to x. So we'll deal with the constant, and now we can factor the binomial x expressions to isolate the x squared term from its coefficient. And now we'll do our trick to complete the square, in this case by adding 18 to both sides. On the right hand side, it's a 9 enclosed in the multiplication by 2. That lets us factor out a perfect square, and now we can move our constant to the right side to isolate y. Now that might seem like an awful lot of work to basically just restate the same equation a little bit differently, but it's now in something that we call vertex form, and more generally we write it like this. Now the neat thing about vertex form is that it includes the coordinates of the vertex. It's at hk, and that of course tells us that the x value for the line of symmetry is h.